Welcome. In any efficient steam system, managing condensate and air is critical. Today, we're looking inside a key component used by steam fitters and pipe fitters worldwide, the Spirax Sarcofloat and Thermostatic or F&T steam trap. This is a 2.5-inch model, commonly found in industrial steam systems. Let's explore what it is and why it's essential. An F&T steam trap is a mechanical device designed with a dual purpose. Its primary job is to continuously discharge liquid condensate from the steam system as soon as it forms. At the same time, it must prevent the escape of valuable live steam. It achieves this by combining two distinct mechanisms in one robust cast iron body: a mechanical ball float for condensate and a thermostatic air vent for gases. Let's look at the three key functions. First, discharge condensate. Second, vent air and non-condensable gases. And third, prevent live steam loss. Now let's look at how the float mechanism handles condensate. Inside the trap, you can see the key internal components: the stainless steel ball float, the lever arm, the main valve and valve seat, and up top, the thermostatic air vent capsule. The float mechanism operates on the simple principle of density difference between steam and liquid condensate. As condensate enters the trap body through the inlet, it pools at the bottom of the chamber. This rising liquid level lifts the hollow spherical ball float upward. The float is connected to the main discharge valve via a lever arm. As the float rises with the condensate level, it pulls the main valve off its seat, opening the discharge port. The system pressure then pushes the condensate out through the outlet. When the condensate level drops, the float drops too, and the valve closes. Here's the crucial point. The main valve is always submerged in condensate. This creates a liquid seal that absolutely prevents live steam from escaping through the main discharge. Because the float responds continuously and proportionally to the condensate level, the trap discharges condensate steadily, making it ideal for applications requiring consistent heat transfer. Now let's look at the second mechanism, the thermostatic air vent. Air and non-condensable gases are a serious problem in steam systems. They act as insulators, drastically reducing heat transfer efficiency, and they can cause corrosion. They must be removed. This is where the thermostatic element comes in, located in the steam space at the top of the trap. During a cold startup, the balance pressure capsule is cold and contracted, keeping the air vent valve wide open. This allows large volumes of initial air and non-condensable gases to be purged rapidly from the system. When hot steam finally reaches the trap, the temperature rises. The special fluid inside the capsule vaporizes and expands, pushing the capsule outward. This expansion forces the air vent valve closed, sealing tightly against the steam so no live steam escapes through the vent. During normal operation, if air or non-condensable gases accumulate in the steam space, the temperature of the mixture drops slightly below the pure steam temperature. The capsule senses this temperature drop, contracts slightly, and opens the vent to discharge the accumulated gases. Once the pure steam returns, the capsule expands again and closes the vent. This cycle happens automatically and continuously. Now you can see both mechanisms working together in the same trap body. The ball float and lever handle the continuous drainage of condensate at the bottom, while the thermostatic air vent manages the intermittent release of air and gases at the top. They work independently but complement each other perfectly. The float responds to liquid level, the capsule responds to temperature. Together, they ensure the trap removes everything that needs to go, while keeping the live steam where it belongs. So why are F&T steam traps so important for efficient steam system operation? Let's review the four key benefits. First, continuous condensate discharge. The trap removes condensate as soon as it forms, which is vital for processes needing steady heat transfer, like heat exchangers and heating coils. Second, excellent air venting. The built-in thermostatic vent ensures rapid air removal on startup and during operation, preventing a condition called air binding, which can stall heat transfer completely. Third, they handle variable loads with ease. The float responds instantly to changes in pressure and flow rate, whether the condensate load is heavy or light. And fourth, energy efficiency. By preventing live steam loss and removing insulating air, F and T traps maximize the thermal efficiency of your entire steam system. Understanding the float and thermostatic steam trap is fundamental knowledge for any steam fitter or pipe fitter. Thank you for watching, and good luck on your Red Seal exam.